Recently, I was helping Jake work on a unit, and we were having all kinds of problems with frequent regenning on the after treatment. And he had changed the after treatment element a year ago. This is an X15 with the unitized element, and those elements just don't have problems, okay? They'll last usually 3 years, 4 years, if the engine's running properly before they need to be cleaned or replaced. And this has been a year, and the truck's been nothing but trouble with the after treatment. So I went down there and we pressure tested the entire system. That checked out okay. He had already changed the injectors, and that didn't really make that much of a difference. That probably gained us 4 or 5 hours. Instead of regenerating every 6 to 8 hours, we're regenerating about every 15 hours now, but that's still way not acceptable for that engine. It should be up above 50 hours, even in a bad duty cycle. So we went through everything, and I went down again. We took apart the EGR sensing housing. It had a lot of carbon in it. We cleaned all that out, put it back together, put a couple new sensors in, and then I had them do a driving log. And when they did the driving log, I noticed that the EGR flow was really low for the amount that the valve was open. And so I want to show you the data log and talk about it a little bit here today. So let's take a look. So here's a portion of the data log, and over on the left you see where the left column is EGR cooler efficiency in percent. That should always be 100 or 99. Once in a while I'll see one at 98. This one is when we're at maximum throttle and the engine's working hard. It drops down to 96. There's another part in this log where it gets as low as 92. So why does that happen? Well, there's a couple reasons. One is the EGR differential pressure, which is being accurately measured in this engine because we've cleaned the housing out, installed a new correct part number EGR differential pressure sensor. There's a new exhaust gas pressure sensor in that housing, and there's a new exhaust gas pressure sensor in the back of the thermostat housing where it measures pressure in a manifold, exhaust manifold. So we're at maximum throttle, and you can see we've got in the exhaust gas pressure, second column from the right, we are between 100 and 125 inches of mercury in exhaust gas pressure, and we've got 57 inches of boost at one point. And the boost number is right for the horsepower of this engine. I already checked that. And our EGR flow should be probably about 2 to 3. In other words, 2.0 to 3.0, somewhere in there. And it never gets above about 1.5 in this entire log. And they took the truck out, they drove it down the road, down the freeway, up a very steep, about a half-mile hill. Part of that maximum throttle is that hill. Then they went down a long hill, and then they just drove it partial throttle down about 3 miles of road at 35 miles an hour. And the truck is a roll-off, and it didn't have a container on the back, so it probably weighed about 40,000. So that's enough weight to make the engine work. So the EGR valve position, commanded and measured, was right on. The EGR valve was working, but the EGR cooler was not flowing. So I had them replace the EGR cooler because it was restricted. And when that happens, it causes the rest of the system to get out of whack, if you will. So we put an EGR cooler on it. This engine also had a broken exhaust bolt. You saw that video earlier with the drilling out of the broken bolt. So Jake's going to do another road test with the new DPF, with the replacement EGR cooler, the exhaust leak repaired. He's going to send me that log. He's also going to do a regen and send me that log. And we'll take a look at the difference in the EGR cooler efficiency. One thing I didn't talk about that it might be interesting to you is the DOC catalyst had about 3 cups of soot on the face of it. It's amazing it wasn't logging face plugging faults. And when he pulled the exhaust pipe off the turbo, there was a layer of carbon build up. So that's how much soot was coming out of that engine. I can imagine the EGR cooler was extremely inefficient due to soot plugging. Because don't forget, the EGR coolers normally are full of moisture. When you start those things up and let them idle for a few minutes, if you pull that back off of the EGR cooler, the gas pipe for air that goes up to the EGR flow manifold, it'll be full of water in there. And that's normal. That's condensation. So then when you start up and you got soot, that soot mixes with the condensation. It gets baked on the tubes, and the rest is history. So once I get the new log and the regen log, we'll take a look at that. And you guys can see if we fixed it or not. Okay? See you next time on Engine Shop Joe.